Hello, and welcome to this tutorial with Mediapipe using an embedded system to perform gesture recognition. We're going to be going over a brief overview of our project here with all the different components and hardware components we're using in our embedded system to perform this gesture recognition. We're then going to go over a list of commands by running the app to see what the user can do in the terminal, and finally a demo of the gesture recognition itself. As a brief overview, with Mediapipe, we have 21 landmarks using hand gesture recognition. These landmarks have a normalized value between -1 and 1 by looking at the wrist coordinate, the XYZ coordinate of landmark 0, and comparing it to all the other landmarks with all their respective XYZ coordinates. As for gesture recognition itself, using our embedded system, the BeagleY-AI, we can see in the middle here that we have the BeagleY-AI, which runs a gesture recognition loop using Mediapipe hand tracking, running by cross-compiling with Bazel. Essentially, with our program, Mediapipe actually runs by taking the Linux virtual machine executable and cross-compiling it to the BeagleY-AI, which uses ARX64 as its runtime. As for the hardware components on the BeagleY-AI, we have it as follows. Here's our BeagleY-AI, and it has various components, such as the joystick, rotary encoder, the audio encoder, and the USB webcam plugged in via this USB-C port right here, this USB port. The USB-C output here gives us power to our BeagleY-AI. And this essentially allows us to use the network file system to interact with the Linux virtual machine and the BeagleY-AI simultaneously. Now at runtime, the BeagleY-AI connects to the server. It uses the network file system to connect the webcam. It uses the various hardware components such as the joystick to start the recognition, rotary encoder to stop the recognition, audio encoder to play a certain sound based on the gesture recognized, the actual webcam itself to see the different gestures, and the LCD display to display different state information or information on what gesture was recognized. And as explained earlier, we need to cross-compile from the virtual machine to the BeagleY-AI using Bazel. Bazel is a build tool allowing us to take all of our Mediapipe source files and put them onto our BeagleY-AI so it can use it during runtime. And this runtime compilation allows us to use real-time gesture recognition that is happening on the BeagleY-AI itself, so that we're performing this on the hardware rather than relying on some separate software which may have some kind of blocking in place. Now, as explained earlier, there is a game here. Let's say that we had multiple BeagleY-AIs. In order to start our game, we need two. Those two Beagle boards would connect to the same central server, start a game by creating a name, creating a room, joining that room, and typing ready into the terminal. When both boards are ready, a game will begin, where these boards will verse each other by performing different gestures to build the tower and defend their tower and attack the other player's tower. The user who builds their tower to the max height first wins the game. So a central server acts as a sort of middleware between the BeagleY-AI and the web client. This ensures full synchronization and state management amongst all boards, amongst all active games, and amongst all web clients. This essentially allows multiple active game sessions and unlimited active boards connected. Some of the moves include attack, defend, and build. Those are the three gestures that are recognized, and we're essentially looking at the landmark data, as explained before, to determine this kind of gesture. As for a brief overview on the web client, we're essentially just using React with frame of motion for animations, and we're connecting with WebSockets from the web client to the web server. The BeagleY-AI itself is using C++, which also has its own WebSocket information connecting itself to the web server. Now it's time to go through some of the commands the user can use, and also a brief demo over the gesture recognition itself, seeing how it can perform on the board and what kind of results we'll see. So we essentially have our web server, which is connected to our web client as seen here, and then our Beagle client in the terminal. We can then perform different commands like setting our name to GK, creating a new room like room 10,000, and that room is given an ID. That is then passed over from the server using HTTP WebSockets to the web client. We can see here that it then updates the web client with our new room, and then we can use a room ID given to that room name to then join that room. Our name, as seen here, is visible on that room on the web client. And then we can ready our state, and it sets it to ready. So we're essentially using our WebSockets to transfer information from our Beagle board, the embedded system, to our web client. There are of course various other commands used with gesture recognition, but these are some of the basic ones when it comes to room management. Now let's look at the gesture recognition itself after looking at the room management. If we press on the joystick here, it will start the gesture recognition by turning on the camera and taking gestures. We can, for example, do a defend gesture, like so. This will then send information using landmark data to the Beagle board, and then from the Beagle board to the server, and then from the server to the client if the user is in an active game session. Now we can also do other moves like build, which is a 2, and an attack, which is a 1, and all this information is sent at runtime to the server to update the client if the user is in an active game. We can then click the rotary encoder, which, if the user is in a game, it will send that information properly to the server so that it can then update the web client if the user isn't around. In addition to the joystick and rotary encoder, we are also using the LCD and the audio encoder. The audio encoder will play audio based on what gesture was recognized. So let's say we do the build gesture. This will then play a certain build sound as well as showing build on the LCD itself. Additionally, the web client will be able to send information if the user is in an active game to the server, and then from the server to the Beagle, and the Beagle will be able to show that on its LCD. So not only are we able to show information from the Beagle to the web client, but we're also showing it from the web client again onto the Beagle then. So, in conclusion, we have different components interacting, such as an embedded system, interacting with an HTTP WebSocket server, interacting with a web client. And these different components are then combining and having different actions occur with gesture recognition to send data between each other. And in the case the user is in an active game, we're able to have multiple Beagle boards versing each other to play a gesture recognition game.
We have 3 different components. We have a web client that shows game state and allows joining and creating of rooms. We have 2 players that each run a C++ application hosted on their specific Beagles. So the first thing we're going to show is starting and joining a room. For example, player 1 here, he can start the game with sudo /game, and it'll initialize all our modules and then give you a bunch of commands. First, you have to set your name so we know the name of the player joining. Then we're going to create a room. The name of that room is 700, and if you go here, you'll see immediately the web client is updated and automatically joined the player, as you can see from 1 out of 2 players. Next, we're going to have player number 2 join that same room. He's going to set their name to Wes, then he's going to join that room with that room ID that we showed earlier. Perfect, and now immediately you'll see the web client update with 2 out of 2 players full. So now, we're going to click on the view room, we're going to view that room. Perfect. Now you'll see both players are not ready. And you'll also see the gesture tower, the Beagle board indicate that it is ready. So first we have to send a ready message for both players. You will send one, you'll see it'll automatically update is ready. And now once our second player sends that ready, the game will immediately start. And it'll update the LCD to show game starting. Once we click this X up here, the game will officially start and rounds alternating will begin. Music will start. Round 1 with 3 different cards, 1 attack, 1 defense, 1 build. And round 1 here for the other player, attack 2, defense 0, and build 1. Both players can now do gestures, as you can see here, by clicking on the joystick, which will start the gesture detection and be able to send a card. Defend detected, and then we'll send it with the rotary encoder, which sends it immediately. Other player will do the same, which immediately updates the game state. And then as soon as that, it'll progress to the next round, 30 seconds, with new cards. And now they have to do the same thing again. I'll back up and they'll both do it at the same time. One sent to build and one sent an attack. And it plays both animations. As you can see, it'll continue on to round 3 with 3 new cards. And the game continues till you reach the win condition of reaching your goal.